6.4, number 8. The sum of two numbers is 25. So in these types of questions, you'll find usually that one sentence gives you sort of the information for one equation. So we have here that, I don't know, I'm just going to do x plus y. X plus y is 25, okay? The sum of their reciprocals is 1/4. Determine the two numbers. So if you want, you could just go, their reciprocals sum equals 1/4. Okay, so that's a good place to start. What you want to do, though, is you want to take this information, both pieces of information, because usually there'll be two main pieces of information in the question, and you want to make one equation with one variable. All right? Let's just put that over here on the side. One equation with one variable. Okay? That's really important. So in math, going forward, pre-cal 20, pre-cal 30, calculus, AP, university calculus, doctorate, saving the world, okay? All of it. This is what you do, okay? This is the basis of all of that. So one equation with one variable. Well, I have two equations, two variables. So what you should know by now is that you want to isolate one of the variables in one of the equations. So I would probably isolate the y over here. It's a little bit easier than isolating the y over here, right? But really, I guess you could isolate the y in either of them and then substitute into the other. So get one of the variables all by itself. This one is super easy to do. And why is that important? Well, because now I can combine these two and I can make one equation with only one variable. Why? Why? Here's the why. This y is actually equal to 25 minus x. See that? So if I substitute that in, then I have one equation with one variable. And I have included the information from here and the information from here. So here's my one equation. I'll do this in red. 1/x plus 1/25 minus x. You see that? Because that's what y equals in the same question. So I'm shoving them together. Equals 1/4. Now this looks like a rational equation, right? We're going to solve a rational equation. That makes sense. 6.4, that's what we're doing. So you're on the right track if you're here. So common denominator, when we're just adding, okay, so if we actually erase this and I say add these, you get a common denominator so you can add them, right? But with an equation, you can multiply by the common, lowest common multiple of all these, multiply, and then you want to eliminate the denominators, so you have a regular old equation, which is easy to solve. So we're going to multiply by the lowest common multiple, which of these is just this factor times this factor times this factor. Now don't get crazy and say, well, I'm going to multiply just by x, and then by 25, and then by 4. Remember, you can't pick and choose just parts of a factor. You have to deal with the whole factor at a time. So I've seen that too. So I'm going to multiply by x, and by 25 minus x, and by 4. Because when I multiply this whole thing by each one of these terms separately, then I'm going to eliminate all the denominators because there is a common factor, top and bottom, for each of those multiplications. Okay, now we're going to black. So this first one times this big chunk here, well, the x's will cancel out. You see that? So I'll just show that real quick there, and I'll back that off. But the x's are gone, and I'm left with 1 times this one times this one. So that's just 1 times 4 times 25 minus x. Yeah, you don't need to write the 1, of course. But we have no denominator. Awesome. The second one here now, okay, is the 25 minus x will divide out, and I'm left with 1 times x times 4, right? That's just 4x. I'll leave the 1 alone there, and I'll get rid of the 1 here now too. And now this one, this big chunk times this one, the 4's cancel out, and I'm left with x times 25 minus x. So is everyone okay with that? That's the big deal here in these questions. Besides getting the two original equations, that's a big deal. BD, right there, that's a big deal. This is a big deal right here, determining what to multiply by, and getting here, another big deal, okay? BD, that's a big deal. I hope BD doesn't stand for anything else. That's embarrassing. Big dog. That's the big dog part of the question. Yeah, anyways, that's dumb. Okay, so you guys are good now, though, for this, up to this point? So now we expand, gather like terms, isolate for a variable if we can. Probably going to have a quadratic. I'm seeing a quadratic here somewhere, like maybe x times x here is going to give us a squared. So All right, so let's just go ahead and do that. Okay, so we multiplied everything, gather all like terms, pull everything over to one side, and then you've got a quadratic. So to solve, you can use a quadratic formula if you want. X equals negative b plus or minus root b squared minus 4ac all over 2. A. Very Canadian song. All over 2a.
Wait, why would you say it's very
2a. It's all over 2a. You know, like 2a? Like this? 2a? Okay, forget it. Forget it. Well, you don't have to think it's funny. It's like teacher funny. Maybe not cool teenager funny. Can we do this though? Are the roots we can? Do you think?
Yeah.
Okay. What are the factors of 100 that give us a sum or a difference or whatever of 25? Oh, thank you. So x and x, 20 and 5 are our numbers for sure. So they either both have to be negative or both have to be positive, right? And the sum is negative, so minus 5, minus 20. Now, that means the possible solutions are positive 5 and positive 20. We do have to examine this for reasonability, though. The sum of two numbers is 25. The sum of their reciprocals is 1/4. So, grade 11s, can I just pause here, please? Just pause here. So if one number is 5, what's the other number? 25 minus 5 is 20. If one number is 20, because this is important, the two numbers are not 5 and 20. The two possible x values are 5 and 20. They happen to be identical, right? But this is not always the case. This is not always x and y, because look at, these are both values for x. So the other combination would be 20 and 25 minus 20, or 5. So you get the same combination. That's the only combination that you get. But please bear in mind that when you solve for x, these possible values are just the x. They're not the x and the y, right? They both equal the x. So it appears that the numbers are 20 and 5. Let's do a quick check. 1 over 5, what is that? Plus 1 over 20 should equal 1 over 4. Does that make sense? Well, I'm going to multiply this by 4. Multiply this by 4. That's going to be 4 over 20 plus 1 over 20 equals 1/4. 5 over 20. Does that equal 1/4? It does. Boom. Okay, so there's our little check. You can do that in your head or whatever, and those are your two solutions. So the two numbers are 20 and 5. Clearly indicate that. Circle. Okay, the two numbers are 20 and 5. Okay, does that help for number 8 there? Good. Big deal. Very big deal. All right.